The partial sum of the geometric sequence is given by the formula S of n equal a times 1 minus r to the n divided by 1 minus r. Okay, and for r is not 1. Find the partial sum S of n of the geometric sequence given by a equal 5, r equal 2, and n equal 6. So S of 6 is equal to 5 times 1 minus 2 to the 6 divided by 1 minus 2. Okay. Well, in the next one, well, we don't know what is r and what is n here, so we need to figure it out. So we given a equal to negative 15, a sub 2 equal to negative 15 times r equal to 30. This means r equal to, okay, r equal negative 2. And we need to figure out what term is this that is negative 160, 960 I mean. So a sub n is equal to negative 15 times negative 2 to the n minus 1, and that equal to negative 960. So this is negative 2 to the n minus 1 is equal to 64. Okay, so 64 is negative 2 to the 6. This means n minus 1 equals 6 and n equals 7. So here we are looking for the partial sum of the first 7 terms. N equals 7, S of 7 equal to negative 15 times 1 minus negative 2 to the 7 divided by 1 minus negative 2. And that is negative 645. In the next term, for here we are given that a equals 64. The common ratio r equal to 32 and n equals 6. So f sub 6 equal to 64 times 1 minus 3 over 2 to the 6 divided by 1 minus 3 over 2, and that is 1330. Now take a look at the infinite series. For the infinite series is the expression in the form where we actually add infinitely many terms together, like all the terms as n go to infinity. Okay. For example, this paradox, that is with locomotion, must arrive at the halfway stage before it arrives at the goal. So for example, it's saying that, say if you stand in here and you want to get to this door. In order to get to this door, you have to make it to halfway to the door. Okay. In order to make it halfway, after you make it halfway to the door, in order to make it to the door, you have to make it a fourth way to the door, to the 8th way to the door, so on and so forth. And as you know, this sequence of 1 over 2 to the n, where n here is infinite, n here is getting larger, n is approaches infinity in this case. This meant that 1 over 2 to the n this value here is also approaches infinity. And 1 divided by infinity, a very large number, is approaching 0 but never actually be 0. So according to this paradox, you never actually walk through that door. You can get closer and closer and closer to that door. So this paradox tells you that you can't even go to that door. Alright, so the partial sum of the given series is given at s equal 1, s2 equal 1 plus a half, 1 plus a half plus a fourth, 1 plus a half, a fourth, and 8, so on and so forth. Okay, so note that as n approaches infinity, 1 divided by 2 to the n approaches 0, and we can see that s of n approaches 1 and as n go to infinity. So in general, if s of n get close to an infinite number s, as n go to infinity, we say that the infinite series is converged, okay, or convergent. The number s is called the sum of the infinite series. If an infinite series does not converge, this means that it's diverged. Okay, so let's take a look at this. Infinite geometry series, if absolute value of r less than 1, then the geometric series is converged and have the sum that s equal a divided by 1 minus r, and it diverges if r is greater than 1. So let's take a look at here. Determine whether the infinite geometry series is converged or diverged. If it converges, then find the sum. So from 1, so here we noted that a equal 1. A sub 1 equal to negative 1. A sub 2, a sub 1 equal 1. A sub 2 equal negative 1. A sub 3 equal 1. So this is the geometric series of the form a sub n equal 1 times negative 1 to the n minus 1. Well, here r equal to negative 1, absolute value of r equal 1. So this tells us that this series is diverged. The next one, a sub 1 equal 1, a sub 2 equal negative a half. So that is 1 times negative a half. A sub 3 equal to 1/4. That is 1 times negative a half to the second. So here a sub n is equal to 1 times negative 1 over 2 to the n minus 1, where a equal 1, r equal to negative a half. So absolute value of r is less than 1. So this series converges. And let's just find the sum. So s equal to a divided by 1 minus r, 1 divided by 1 minus negative a half, equal 1 divided by 3 over 2. So this series converts to 3 over 2. 2 over 3. Now that we have, let's take a look at this interesting one. When we divide by a number, we get fraction. We get repeating decimal. This means this number is actually a rational number can convert to a fraction. So how do we convert this to a fraction? I can start rewriting this as so here I'm looking at this. This can be written as 0.7 plus 0.07 plus 0.007 plus so on and so forth. This is 7 over 10 plus 7 over 100 plus 7 over 1000, so on and so forth. So here I can see that, well, then a is equal to 7 over 10 and r equal to 1 over 10. I can find the sum that s is then equal to 7 over 10 divided by 1 minus 1 over 10. So 7 over 10 divided by 9 over 10. So this is 7 divided. So this is 7 divided by 9. So 7 divided by 9 is equal to 0.777, so on and so forth. And you can check this using your calculator. In the next case, well, this is a repeating decimal. So 0.112 repeating. I can rewrite this as 112 divided by 1000 plus 112 divided by the next 3 terms, so 1 million, so on and so forth. So here A is equal to 112 divided by 1000 and R equal to 1 divided by 1000. Okay, so S is equal to 112 divided by 1000 divided by 1 minus 1 over 1000. And this is the fraction.